So I was watching over some of the answers I was getting in the summary view, so I just briefly wanted to go through the first three types of problems in this activity, since these three types of problems basically repeat themselves through the rest. So in problems like this, where we have a set of ordered pairs, the domain is these distinct x values. So for example, 4 is a domain value. -6 is a domain value. 0, etc., etc. And we don't want to list any domain values that repeat. Now, since this is an ordered pair, the way we write the domain is a little bit different. So the domain for a set of ordered pairs, we start with that squiggly parenthesis, and then we list all of the x values. 4, -6, 0, -9. And we have another 0, but we don't want them to repeat, so I'm going to leave that one out. -3 and 10. Now, traditionally, when we write the domain values, we also want them to be in numerical increasing order. So I'm also going to want to rewrite this so that -9, since that's the smallest x value, is first, followed by -6, -3, 0, 4, and 10. So this is how we write the domain when we have a set of ordered pairs. So when it's not on a graph, we just write the domain as a list of the x values. We're going to do the same thing for the range, but we know the range is the list of all y values. So I'm going to do the same thing. I'm going to write them in numerical increasing order, all of the y values, and I don't want any that repeat. So my y values are -2, -8, 5, 2, another -8, 6, and -7. So if I want to write them in numerical order, I'm just going to zoom out so that I can see a little bit easier. My smallest y value is -8. The next smallest would be -7, followed by -2. I'm just scanning here. -8, -7, -2. Followed by 2, 5, and 6. This would be the correct way to represent the domain and range values when we have a list of points of ordered pairs. When we have a graph, these are also just distinct points on the graph. Notice they're not connected by a line here. So I don't include any of the values in between here. I'm just talking about x values of -4, -3, -2, and so on and so forth, only at the x values where these points appear. So the domain for this graph would have x values of -4, -3, -2, -1. Again, x values, this point has an x value of -1. And also, the domain would include 3, because both of these points actually have an x value of 3. Range is going to work in a similar way. I'm talking about all the y values of these points. The smallest y value I see is -6. And as I work my way up, I also have y values of -2, 0, 4, 6, and 8. So that would be how I represent the domain and range when I have a graph made up of all of these distinct points, all of these points that are not connected with a line. When we do have a graph that is connecting points with lines, then we can use the interval notation that we talked about today. So for example, my x values range from -3 with a closed circle over to 1 with an open circle. So my domain for this one would be -3, 1, the 1 having a parenthesis, it's open. My range is talking about all the y values, and my y values range from -2 with a closed circle all the way up to +4 with an open circle.